So here's the formula we have. D is equal to Vf plus Vi over 2 times t. We can rewrite this bad boy. D is equal to Vf plus Vi over 2 times t. Now we want to get t by itself. There are a bunch of tricks we can do. First of all, we can bring the t along with these two guys to make them together. So d is equal to Vf plus Vi t over 2. Now we got to get t by itself. So if we times both sides by 2, 2 here, 2 here. The 2 cancel out on the right hand side, and then we're left with d is equal to Vf plus Vi t. Now I chose not to distribute this guy throughout t and Vi and Vf. So we can divide both sides by Vf and t, and we can get we'll get 2d over Vf plus Vi is equal to t. Now if you go back here, because t was initially over 1, they multiplied, but I chose not to FOIL t out through. So as a result, when I went 2 down, 2 went away, and we were able to get to what we want. So the question we're presented with is, a 1,000 kilogram car is traveling at 15 meters per second. As it approaches a stoplight, she attempts to slow down with a deceleration of 2 meters per second squared. How far does she travel before a stop, and how long does it take her to stop? Okay. Whenever I'm presented with a question like this, I usually do a trick, and I call this DALP. D-A-L-P. Draw a little, I should really get that fixed, picture. According to our thing, we have a car, draw a little car, going this way. There's a stoplight with a red sign. So we know that she's traveling at 15 meters per second. But there's a little trick here. She has a deceleration of 2 meters per second. So 2 meters per second this way. And she's going to stop when she gets over here. Yeah. Now my second technique to do is to write down everything we're given. First of all, we're given mass. So I'll pick a color for this blue. Mass is 1,000.0 kilograms. We're given the initial speed, initial velocity at 15.0 meters per second. She attempts to slow down with a deceleration of this. This is important here. Attempts to slow down with a deceleration, which means that whatever speed she's going in here, she has a negative velocity slowing her down. So we know that the acceleration is negative 2.0 meters per second squared. How far she traveled before she stops. This is important. This tells her our final velocity. Vf is equal to 0. We gotta find two things here. We gotta find her the distance she travels, how far, and her time. So d is question mark, and t is question mark. Let's go with distance first. If we pull out our formula sheet and look at it, we have to find something that includes VF, VI, A, and D. By the way, just for the sake of it, M is pretty much useless in this case. We don't even need it. I don't know why I wrote it down. So, I recommend we go for this guy. VF squared is equal to VI squared plus 2AD. So if we were to do that, VF squared, I should look for a different color for this. VF squared is equal to VI squared plus 2AD. First of all, we know this is equal to 0, so this doesn't matter anyway. So we have these two, we gotta get D by itself. Subtract VI squared from both sides, and we get VI squared. Subtract 2D from both sides, divide 2D to get divide 2A to get D by itself, so we have 2A. I don't know why I keep doing this thing. So, this is our final equation. And we can use this to get D. So VI, we said earlier, was 15.0 squared, move this guy out of the way, over 2 times negative 9.8. No, not 9.8. What's wrong with me today? 2.0. By the way, just so you know, there's a negative over here, but the negative won't actually make a difference here. It's just there for show. Now I'm going to fast track a bit in my calculator to quickly do this. 15 squared over 2. Then we get 56.3 meters before this thing has to stops. Seems simple enough, right? Okay. This is a picture. Now, all we gotta do now is find time and we can call it a day. If we go back to our handy-dandy formulas, what do we have that we can use to find t? Well, we can use this guy. We can use this guy now that we have d. We can't use this guy, so I recommend going for this guy. This is the simplest one. So, VF is equal to VI plus AT. VF, as we established earlier, is 0. So, get t by itself. Negative VI over A. We'll give it time. Now, my physics teacher once told me that time can never be negative, ever. If you get a negative time, it either means one of two things. Either you broke physics, or you did it horribly wrong. And if you check earlier, the math will work itself out so that time ends up being positive. Now, we had 15 as our initial velocity, with a negative sign there, times negative 2.0. This will give us our final time. So the time it took is 15 divided by 2. Wait, why did I do that? I didn't notice one. Is 7.5. And there you go. How far does she travel? 56.3 meters. How long does it take? 7.5 seconds. Yeah. Thank you for paying attention to this video, and good luck in all your future physics and math studies.